Hello, welcome back. In this video, we're going to talk more about the fundamental theorem of calculus. So I'm going to go ahead and kind of review for that real quick for you. The fundamental theorem of calculus, remember, it says if we were to take the antiderivative from a to b of f prime of x dx, let's say, this is going to give us the difference in the values of the original function. We've talked about this before. Remember, the left side, I'm sorry, the right side here, is the change in the y values. In other words, this is delta y. Likewise, the left side, remember, is our area. We've been talking about how the integral itself finds area for us. So this is saying to get the area, all we have to do is calculate the change in the y values. So we can apply this in order to find not just displacement, but my original position, which we're going to talk a little bit about later on. But right now, we're going to take a look at it very simply. So let's say we're given the following derivative, dy dx is 3x squared plus 4x minus 5. Remember, since this is a derivative, this tells us how the function's values change, how the function changes for us. So we can use that to help us find, one, the function, and also how much the values of the function changes. And in this case, we're also given some initial condition. Y of 2 is -1. This is kind of like we can think of it as our start value. And we want to find y of 3, our end value. In other words, we want to find my new y value. So to do that, we can integrate, and that's one way we can do this. We could integrate this expression right here, the integral 3x squared plus 4x minus 5 dx. And I could use this to solve for the original function. And if I were to do that, we would just get x cubed plus 2x squared minus 5x plus c. From here, we can find c. Uh, we can use the initial condition they gave us. Y of 2 is -1. Plugging this in, we would get -1. 2 cubed is 8, plus 2 times 2 squared is also 8, minus 10 plus c. Solving this, we would get c is -7. So our original function with this initial condition would be x cubed plus 2x squared minus 5x minus 7. Well, from here, I can calculate y of 3 now. And I can do that pretty easy. Y of 3, this would become 27 plus 18 minus 15 minus 7. And this just turns out to be 23. So one way we could solve this is by finding the original function, finding our initial condition, using our initial condition to find c, and then we can plug it in, plug our new y value that we want to find in, our new x coordinate in, and then we got 23 right here. But there's another way we can do this, and this is the beautiful way. I think it's a very beautiful way. It's called using the fundamental theorem. And to do so, we are going to integrate. We're going to use an definite integral instead of an indefinite integral this time. So remember, so I'm going to zoom in here a little bit. Remember, this is just saying that the antiderivative from a to b, the integral of the antiderivative, is just going to be the difference in the y values. In other words, it is saying that the area, remember, is the difference in the y values. In other words, the area is the change in y on a certain domain. So let's try this. So I'm going to set this up. I need my a and b. So when I rewrite this, my a to b is very simple. I'm starting at 2 and I'm going to 3. 3x squared plus 4x minus 5 dx. That's going to equal f of 3 minus f of 2 right here. So I am going to evaluate this. Now, I'm going to have some fun. I am going to use Desmos, which is why Desmos is right over here. And I'm just going to type this in. All you have to do is type in integral, int, and I'm going to type in the bounds from 2, up arrow 3, and I just type in my function, 3, you need parentheses, 3x squared plus 4x minus 5. Close your parentheses, don't forget your dx, and once you type it in, it gives me 24. So what that says is this 24 right here. Remember, this 24 is my change in my y values. In other words, this says as x goes from 2 to 3, that's what this says, as x goes from 2 to 3, the y values increase by 24. So we can kind of do this in our head. Remember, we're starting at y equals negative 21 up, negative 1 up there. If I take that negative 1, whoops, that negative 1 where I'm starting, and I add 24 because that's what I'm going to increase by, I should get 23, which is the same answer we got above. So that's what the fundamental theorem does for it. It just gives me how much I'm changing my y values. All right, so but to solve this, we are going to say 24 is, and f of 3 is what I want, f of 2 is what I'm given. That's this negative 1. So this is the equation that we actually want. And all I have to do is solve this. So therefore, I can say, remember, that's just negative 1. F of 3 is just going to be 24 minus 1. I'm just going to solve it algebraically. So that just becomes 23 again. And this is a lot quicker for us to solve, especially if they say, hey, use a calculator. So let's take a look at another example. Sometimes there is no antiderivative. So for the first example that we've done, we could do this either way. We could use method 1, finding C, which again, it's easy, it's fun, you can do this. It takes a little bit more work for us. Or you can do method 2, which is just really quickly because I'm just going to use Desmos or a calculator to get that information anyways for us. For the next one, though, we can solve. So let's take a look here. FTC. So this is what we call this like the FTC problem, and we know we're going to have to do it. So first thing they're going to give us is a derivative. So f prime of x is sine of x squared. This is a derivative. And they're asking us to find, and they give us f of 2 is negative 5, my initial condition, but they give me the value of f of 1. I want to find that value. So they give me a derivative. I want to find the value. I have to use antiderivatives right here. So I'm going to set this up. This is our typical FTC problem. This is all the FTC problem. And when we evaluate our integral, we're starting at, we're, my known value is at 2, and my next x value is 1. So I got these two x values here. We typically put the smaller one on bottom. It doesn't really matter. If you put the 2 on bottom, just make sure you make it negative. This is going to go sine x squared dx, don't forget your dx, is equal to, and now we get the FTC part, the change in my y values, f of 2 minus f of 1. And this, I'm going to type in my calculator. I'm going to go over here, and I'm just going to type in exactly as it looks, integral from 1 to 2 of sine x caret 2. Please don't forget your dx, and there's your answer. Go to 3 decimal places. This is your FTC. And so this is going to give me 0.495 equals f of 2 is what I know, f of 2 minus f of 1, or 0.495 equals, this we know is, let's see here, f of 2 is negative 5 minus f of 1. And I'm going to solve it. F of 1, therefore, is just, what's that, negative 5.495. And there's our value. Very easy to do. So how do we grade this? You have to have this FTC step, +1. Plug in your calculator, +1, and then your answer, +1. Very easy to do. So let's take a look at what this kind of means for us. If we were to look at this kind of graphically, this is saying on the domain 1 to 2, I'm starting at -5, not drawn the scale. So at 2, I am at -5. There I am. And what this is saying is on the domain, if I were to go from 1 to 2, we have increased our x values by, what's that, by 1. So my change in x is 1. Well, as we increase our x values, what happened? Well, we increased our y values by 0.495. Of course, we're starting with a negative, so I should just make this correct. Let me go and make this a little bit more correct for us so it looks more correct. So there we go. Terrible, terrible of me. There we go. So if we're going from 1 to 2, my x values are increasing by 1. I'm starting at -5, 2, or sorry, 2, -5. So as my x values increase by 1, my y values have also increased. Remember, I'm starting here at 1, so I want to start here. So I'm at this -5.495, and I had to go up 0.495 to get there. So what we're seeing is just our changes in our x and our y's. And if you notice, if this is my change in my y and that's my change in x, that's really a slope. That slope is really what we're going to call later on the average value. And that's going to look more complicated later on. All right, come back for video number 2. We'll take a look at some examples from your homework just to show you how quickly these go, because everything's going to be on Desmos tonight. All right, hope you guys have some fun. See you later.